All right, we've got just a little up. It's 10:45. My time has started. So is the mic working and everything? You can't hear it from up here. You can't tell one way or the other. All right, so welcome to the session. My name is Steve Goodrich. I am a senior principal software engineer at Ivanti, and I've been there for about 11 years. And the whole 11 years I worked on device management. So Ivanti does a lot of stuff. We have service management, asset management, license management, all kinds of management. But I know device management, so that's what you're going to hear about today. What we're going to talk about is using specifically the Ivanti endpoint management software to enforce state on your machines, and then some other stuff. I'm going to spend a little bit of time showing some of the things we're doing now that will kind of move into the future, hopefully move the whole LAN desk thing forward finally after 30 years of being pretty much what it is now and what it has always been. So, before I start, how many of you guys are current Ivanti users? Okay.
Of any product or?
Yeah, I guess of anything. How many of you use EPM now? All right. Okay. So this is going to be a fairly technical talk because engineer, right? And so we're going to go into some interesting details. Hopefully you'll get some good stuff out of it. Feel free to ask questions. One thing I've learned from this conference so far is 75 minutes is quite a long time. I can get a lot of stuff out in 75 minutes and probably answer a lot of questions as well. So we should be good. So the agenda for today, we're going to talk about using patch management. Ivanti has a pretty robust, very capable patch management system that you can use to do some things you may not have thought of before. We're also going to look at using custom inventory items to gather information that we don't gather by default. We're going to look at how we manage agent settings these days, how we manage configuration profiles, so the Apple configuration profiles. And then we're going to take a little look into the future with some of the stuff we're doing with the cloud. But specifically, we're going to get really technical with that. And we're going to show, hopefully I won't get fired, we're actually going to show some source code from our agent. Sometimes companies look down on that. I don't know. Showing source code in public, not a big deal. So, for Ivanti, state management is a thing, right? State management says, I am going to take a machine and I'm going to put it in this state and then I'm going to keep it that way. I want this software installed, I want these configuration profiles installed, I want these settings set up, I want to make it that way and then I want to keep it that way. That is not the way most people perceive Ivanti as working. Ivanti really is set up to say, I want to schedule some work to be done on this machine, have the work done, and then maybe check up on it later. That's kind of the paradigm Ivanti generally works with. But you can use patch. You can use some of the other facilities we have in EPM to actually enforce state, more like a policy that you would see in some of the other EPM systems. So the way this works in a nutshell at Ivanti is you get patches, software configuration, and everything down onto the endpoint, and then we keep it that way, probably using patch. So if you're familiar with our software, we're not really into wizards and making things easy. I probably shouldn't say that, huh? But we give you a really good toolbox of a lot of very powerful tools. So that's what we're going to talk about today, some of those tools. And we're going to take this, if we got this big old nice drawer of tools, we're actually going to lift that top shelf off and look at some of the tools that are underneath that maybe some of you haven't seen as much. So it should be fun. So as far as the Ivanti Endpoint Manager goes, we have some primary tools that we use. We have provisioning. How many people have used endpoint provisioning with EPM? So provisioning is a really powerful tool. Provisioning says, I have a whole list of things I want done. I want this software laid down. I want these profiles laid down. I want the machine to have this name. I want these users set up. I want the machine bound to this AD. I want all these things done, right? So you can build these big templates of how you want the machine to look, and you can schedule that to happen to the machine. The thing about provisioning in EPM, though, is it's not state management. It gets the machine in that state, And then what happens going forward is anybody's guess. The user can delete things, the user can change names, and provisioning isn't going to bother with that. It did its job, it got you to where you wanted to be, and now it's just going to leave you alone, okay? Super powerful, but it's really to get the machine up and going, get it set up. Patch. Patch is what we're going to talk about a lot today. Patch does a lot of interesting things, but really what it's about is I want this software to be this way, I want these settings to be this way, I want the machine in some particular state. I have a way to detect if it's moved out of that state, and I have a way to stick it back in that state. Okay, so patch will let you do that. It's not just I want this piece of software installed when it gets updated, right? It does a lot more than that. Configuration profiles for Apple management, that's really important because you have to get those configuration profiles down on the device to do, certificates and all the kinds of setup you have to do for Apple, right? So, software distribution. Software distribution is sort of the user side of getting software down on the machine. A system administrator can say install a piece of software on a machine. Again, in the case, unlike patch, the software will be installed, and once it's installed, what happens from then on is anybody's guess. There's no state enforcement there. But what you get with software distribution is you also get the ability to put things in an end user portal, which is nice because then they can go select the software they want and have it downloaded and such. So it's a little bit, it's less heavy-handed than patch, but it's more flexible because the end users can decide what they want. And then finally, mobile device management. Everybody who buys EPM gets how many licenses? 2 licenses. So for every node you buy, for every desktop node you buy, you get 2 MDM licenses as well. So everybody gets 1 desktop device and 2 mobile devices. It's kind of the way it works. So we're not going to talk about MDM a whole lot, but we are going to talk about it a little bit because Apple has made it very clear you will use MDM to manage your Macs, period, right? Anybody not get that message? Apple's saying, yeah, oh yeah, obviously. Our product manager hasn't figured that one out yet, but everybody else has. So, something kind of interesting. Of all of those services, all of them use this thing called SD client. SD client is a binary that lives down on the endpoint. It's part of the EPM agent. We're going to be talking about another agent later, but for now we're talking about the EPM agent. And it is all about getting software installed. And it does all kinds of cool things. Well, first of all, it downloads and installs software, but it takes into account things like preferred servers. It will do a thing we call targeted multicast, which is a way to do multicast across subnets. It does peer-to-peer downloads. It does a lot of cool, interesting things. It'll do throttling, bandwidth throttling. It will do resume on downloads. It's this downloading monster, right? It does all kinds of good downloading things. So we have SD client. That's our tool. So when you have SD client, everything you do looks like a file transfer, right? So in the past, we used SD client to download commands for the agent, to download configuration profiles, to download everything, because everything that comes down through SD client, you get the benefit of peer-to-peer software distribution. You get the benefit of multicast. You get the benefit of those servers, the preferred servers. You get all these other benefits as well. Plus, SD client knows how to deal with lots of different types of files. So it's not just PKG files. If I send down a DMG through SD client says, oh, this is a DMG. I'm going to mount it, and then I am going to basically recurse on the first thing that's in that file and figure out what to do with it based on that. If I send down a zip file, I'm going to unzip it into a temporary location. I'm going to go into it and find the first thing in it and figure out what to do from there. If once I get into one of those guys, I see a PKG, I'm going to run install on it. If I see a .sh, I'm going to send it off to shell. Little side note, as long as it has the .sh extension, we'll send it to the shell. But if you do a shebang, so you want to do Python, you want to do Ruby, Bash will do its thing. It'll say, oh, this is a shebang. It'll run the right interpreter. So you can do shell scripts, you can do automated workflows. This LD patch thing was kind of a kludge that we did to help with our patching about 7 years ago, but it's kind of cool. You can create a directory with a subdirectory called update, And in update, you put a script called postflight, just a bash script. You zip it all up. And then any other files you want to put in there, anything you need to support that postflight will run, zip it all up, and then give it a LD patch extension, and SD client will do things to it. Really, payloadless PKG is probably better for this, but this is something that got put in years ago and we've never taken out. But pref pane, screensavers, fonts, there's default behavior for all of that built into SD client. So you don't have to worry about getting everything into a package all the time. We'll do a lot of work for you as far as that goes. And again, any of those things can live in a zip file. You could put your DMG in a zip file. It would unzip it, see the DMG, would mount the DMG. And if there's another zip file in the DMG, it would unzip that, and it'll just keep digging its way down until it finds something it knows how to install, and then it'll install it. So it's fun. Does a lot of work. So we have another tool. So we don't just have the hammer. Again, we got the big toolbox. But we have this thing called, we have this massive task scheduler that lives on the core. And it just schedules things, man. It knows how to schedule all kinds of things. So much like the hammer, when you have a big old task scheduler, everything looks like a scheduled task. And everything that happens in EPM runs off of a scheduled task. So if you want to apply a patch, you have to schedule it. If you want to make somebody or give somebody access to software in the portal, you have to schedule the publication of that software. Everything is part of it has to go into a scheduled task, which is a little odd, but it works, right? It works pretty well. We have users that have thousands of scheduled tasks that are doing things, and it's pretty amazing. So yeah, so any action has to go through a scheduled task. And I talked about that. I got a little ahead of myself. So, I am almost exactly on schedule. Excellent. Let's talk about patch. By the way, I'm not going to do a lot of demos. I've had 3 of these presentations in the last little while. 2 of them had horrible, awful technological problems. So it's kind of fool me once, shame on you. Fool me twice, command shift for everything, right? We're going to screen capture it all. We're going to have screen cap, and it works out because, man, I came to this trip, and all of my machines at home decided it was time to go on vacation. And I don't know what's going on with them, and I'm just going to figure it out when I get back. So good thing, fortunately. Uncharacteristically for me, I actually got all these slides done early, and I have screen captures for everything. So we'll talk about patch. So where patch lives. This is the Ivanti console. Yeah, it's a big old Windows program, and that's where it is. That's all we have. So if you want to find patch, down here we have security and compliance. And then once you're in security and compliance, you'll see that panel on the upper left changes, and you will see we have patch and compliance. So if we go in there, then we can look at the types of, we support a lot of different kinds of patches and security content. So I got to put my glasses on for this so I can see it. So all the content is categorized by platform. So we have Mac security content, Windows security content, Linux security content. Maybe people didn't know that we still support Linux, but we do. And in the future, so I'm going to show you later, Linux is being supported in a big way. So Linux is back, full support. We also categorize things by language. So you can select which languages you want to support in your patching. There is a set of international patches that will be pulled down and applied, well, made available to you no matter what language you select. And just as a side note, we also do have a Mac AV. Have any of you used our AV in the past? No? So we've had an AV, some things came up, we switched vendors, and we have new AV, and it's good enough that I run it on my systems. So as the developer, our old AV, I would not run it on my own machines. The new AV, I run it on everything that I have, because it's fine. It doesn't slow things down. I assume it's doing some work, but it doesn't do anything bad to my machines. That's all I expect. That's the best I can hope for out of an AV, any AV solution, right? Is that it's not going to make my machine really slow. So anyway, so we have all kinds of patch content. It's not just patches. It's security type content that will let you do things like, or that will do things like, well, for instance, when File Vault first came out, we didn't have the time or resources right away to put in a File Vault support in the console. Part of the problem, of course, was we're a bunch of Mac developers and we didn't know how to do all this Windowsy stuff. Still don't. But we wanted File Vault support. So we were able to write patch content that would go detect whether File Vault was on, and if not, it would turn it on. Not really a patch, but it worked, and it worked fairly well. So we can do all kinds of fun things with patch. You'll see in a minute. So what we can do in patch. We can maintain state. So we can install software, we can tweak your environment, things like that. We can enforce security policies, so we can remove forbidden accounts, enforce gatekeeper, disable auto login, that kind of thing. And we can do patch. Go figure. And that's just going ahead and saying this version of the software is installed, it's old, we need a new version of the software, so we will update it. So let's look at a scenario of just keeping an app installed. And the scenario I want to talk about is this. We want Discord app installed, not for playing games, but because the Vapor Swift web application framework uses, or their community uses Discord the way most people use Slack. So we want to be able to get on, we want to be able to talk to them about Vapor, we want to find out why our database queries aren't working or whatever. We need Discord on all of our developers' machines. So we're going to enforce that. We're going to put it down there and we're going to keep it down there. So first step is the first step is to go get the discord.dmg. And then we put it in a specific place, and that's this program files, LandS management, LDlog on patch. So once we've put it there, then we go to that where all the patch lives that we walked through a second ago, and we go to that little green plus button right there. And we hit that, and that brings up a dialog to create a new patch. So this is the general information about the patch. You can put descriptions and notes. You can set the severity, all those kinds of things from this screen. But this doesn't really tell you anything about how the patch works yet. To actually create the logic and the stuff that drives the patch, you need to press that little add button there. And when you press add, then you get another dialog that lets you actually enter the patch information. So, so there's a lot of information on this particular dialog. You can select the affected platforms. We'll see that in a second. You can decide which files need to be checked for. You can put in custom logic, bash scripts and such to look at your machine and decide how it works or what's up on it. On the patch information side, the detecting the patch, as a Mac user, you'll probably never use it. So this piece here that says detect the patch. Windows has an interesting feature, an interesting behavior, where a patch can be applied to the machine but not active because it's waiting for a reboot. That doesn't happen very often on the Mac. Usually if a patch needs to reboot on a Mac, you're going to reboot it immediately because if you don't, you risk breaking your machine. So you're never going to get in that state where a patch has been applied but the machine just hasn't been rebooted. And that's really what that detect the patch piece is for. So we'll never really use that. But the patch installation, we'll go ahead and we'll do some work there. So selecting the platform, you have to select at least one. One day we'll remove Mac OS X server because it doesn't exist anymore. But you have to select Mac OS X. And we need to change that to just Mac OS at some point. So then we're going to go ahead and we're going to decide what file needs to exist. So we're going to tell the system that and I'm not sure why I did it this way. I think you can just say applications discord.app and that's enough. I went all the way down. I think I was just, I don't know. Sometimes you just do things because they're there. Anyway, so I'm going to detect whether that Discord binary from the bundle is there. And if you look down further, it says, where it says verify using, I'm going to say just check to see if it exists. I don't care about the version. I don't care about when it was created. I don't care about the size. I just want to check if it exists. And I'm going to say the requirement is the file must exist. That requirement, you can say the file must exist or the file must not exist. You can also say the file may exist, and we're still not exactly sure what that means. The guy who put that one in no longer works there, and we can't ask him. Anyway, but as far as the verify using, I've selected file existence only, but you can also say based on the version, it needs to be at least this version. You can specify the size of the file, I think, to say if the size of the file has changed, then put a new one down because hanky-panky has happened. You can put down the date of the file, require a particular date, and again, if the date's changed, then hanky-panky has happened. So you can have all kinds of requirements. But for this, since we just want the file to exist, we're just going to say the file exists. We don't care about the size or the version or date or anything. All right, and now we talk about how we do the patch. In this case, in unique file name, I have said I want discord.dmg, So on the unique file name, this is the name on the server that we're going to look for. So discord.dmg is the disk image that we're going to be installing. That's the one I put in the Landesk Management Suite Landesk files directory earlier on. Now, I could also put in the manufacturer's URL here. But I've become less and less comfortable doing that just because people move those around, so people aren't, to keep people from web scraping things and stuff. But I could have just put in the URL to the discord.dmg there, and then I could download it from here. But I went ahead and downloaded it and put it in myself. And then I press the calculate hashes, and that calculates a series of hashes. The only hash we use anymore is that SHA-256. So yeah, we still generate the MD5 and the SHA-1, but we are not using them, so don't panic. We use the SHA-256. And it calculates the file size and other information that we're going to use as we download to verify the download and such. So now I've got my patch. I've told how to detect the patch, or detect the need for the patch, and that is if the file doesn't exist. And I've told it that we need to repair the patch using a download, and I've told it what to download. There's one more piece, and this is a little bit strange, but we have to tell it how to install the file. Now, this is what we get when we say execute a program. If I go in and I say add to the patch install commands, and I say execute a program, then I get this dialog, and it has where it says path. You see where it says path there? Those two variables are the path to where the file is going to exist on the client machine after it's been downloaded. But it doesn't have any command to actually do the install. So what we end up having to do is throw in a little command line utility, this user Landesk common LD Gidget. So remember when I said everything happens through SD client? Everything's still happening through SD client. LD Gidget is a symbolic link to SD client. When I started working at Landesk, we had 7 different ways to download a file, depending on how on where it was coming. We had 7 different hunks of code to download a file. One of them was called, we had something called LD Kahuna, and then that would download the file, and then the LD Gidget would install the file. We've consolidated all of that stuff into SD client. So we have one way to do it, one piece of code to maintain, one consistent way for everything to happen. But we still have symbolic links to these old things because LD Gidget just installed the software. I could put in an SD client command line to do the same thing, but I would also have to put in some extra command line switches. And it's more complicated, and it's easier to forget command line switches. It's easier to remember LD Gidget. So rather than having to do a bunch of SD client command line switches, all I have to do is type in user Landesk common LD Gidget, and everything else is taken care of for me. That was back when we used to name things in interesting ways. We had LD Kahuna, we had Stone and Cybok as names of things that happened with patch. It's a pun because the name of the file was Volscan. Anybody know who Stone and Cybok are? We should have a t-shirt if somebody does. They're Spock's brothers. So Volscan, Vulcan, right? Anyway, things are, I guess, different then. So back to the regularly scheduled program. The last thing we need to do then is we have to tell the system we want this thing enforced all the time. So we set auto-fixed to global. With our patch system, you don't have to auto-fix everything. Patches, a vulnerability can be detected. The system administrator at that point would be notified that the vulnerability existed, but then they can decide how they want to roll out the patch. Because you might not want to roll the patch out to everybody. You might not want to roll the patch out immediately, right? So we give you that option. You can schedule the remediation of the problem separate from the detection of the problem. But in this case, we just want those people to have Discord. We're going to say auto-fix it. If it's ever missing, just go ahead and put it back down. So is all this making sense? Is this stuff that... Any questions so far? Okay. So client computers will be scanned on a schedule. If the Discord application is missing, it gets reinstalled. Now, the key piece there is on a schedule, because if some guy deletes it, it's not going to immediately reappear. Under EPM, there is a schedule set by the system administrator, and VolScan will be run on that schedule. And if at that point the application is missing, then it will be reinstalled. So something to keep in mind, that whole scheduler thing, right? Keep that in mind, because later on it's going to become important. So anyway, so that's keeping a piece of software down. So now let's talk about monitoring and remediating security problems. So let's just say for some reason I do not ever want a guest account on any of my computers, on any of my Macs. I can go ahead and I can write a script that detects whether the guest account exists. Now this is kind of a little interesting script, because obviously that first line, that user bin DSCL read users guest, that's going to detect whether the account exists or not. But then we need to get a little bit of extra information in the script that we're going to use to detect whether or not we need to patch the system. So we're going to decide whether or not the guest account is disabled, and then we're going to echo to standard out the string detected, colon, and then either a 0 or 1. 0 meaning no, or 1 meaning yes. And what we're saying is, so remember, we're just writing a script to detect this. Don't worry about how it's going to be run. This is, if we ran this from the command line, this script would tell us whether or not the problem exists. And it would do that by saying detected is either 0 or 1. And if it's a 1, if the problem was detected, then we can output some other information as well. We can output to standard out that the reason was, and we can put any text in there we want. And we can say what we expected to see was, and we can put in any text we want. And then we can say what we found was, and again, any text we want. And then we always exit 0. That exit value we don't care, actually. We don't look at it. People who write custom patches, a lot of times they will echo that whatever they put in detected, rather than putting it in detected. They assume that the 0, 1 being as an exit value will tell VolScan something. They ignore it. So it needs to be in that text. So I write my script, and then I write a script that tells how to remediate the problem. And in this case, we're just going to delete the guest account, right? Then I go in, and I would do these in a separate editor. Always do them in a separate editor. You'll be happier. Then I go into, again, create a custom patch, same way we did last time. We still have to select our affected platform, but instead of going to a file, instead of going to files and specifying a file that must or must not exist or may exist or any of that stuff, we go to custom script, and we just copy and paste our script in there. Okay? And now this is what VolScan will run to detect the script, or to detect whether or not the problem's there. So this is any vulnerability, any state you can detect with a bash script or a Python script or a Ruby script or whatever on your machine. As long as it returns, as long as it prints to standard out these values, we can use as security content. You can go nuts, do anything you like. Okay? Any questions on that? There is one thing that's really nice, because it was a pain for me, so I made the change. We will always take this text and we will strip any carriage returns out of it. Because Bash on the Mac doesn't like carriage returns, but our console's on Windows, and you may end up with some carriage returns in there you didn't expect. So we do always take those out so that Bash will run your scripts happily. Okay, so now we tell in the patch information, we tell the system that we can repair this patch without downloading a file. That's what you see up there. This issue can be repaired without downloading a patch. So the other option there is we can't repair it. So this can be repaired by downloading a file. This can be repaired without downloading a file. And then there's just we can't repair this. We can only detect it. Those are the options that you get there. So, and then in our remediation, in the patch installation removal, so the patch install commands, again, we just say we want to run a script. We stick our script in there. So now I've got a complete piece of patch content with no external stuff. No external things to download, nothing, right? It's all living right inside of our patch content, which is kind of nice. Now, I could have also had it download a shell script if I wanted. I could have saved that bit of text out to a shell script, dropped it in that Landesk files, done the whole setup, and it could have just been the .sh. It doesn't have to be payloadless package, doesn't have to be anything. It could just be the .sh. If I download that, SD client's going to say, oh, this is the .sh, and it's going to run it. So, but for a two-liner, just paste it in, right? If my detection or if my remediation logic was longer, I probably would have done something external. On the detection logic, you can't do that. The detection logic has to all be in that as part of the patch. Okay? And again, if you want to use Python, if you want to use Ruby, as long as you do the shebang, you're cool. Any questions on any of that? Okay. So what about actually just patching stuff? I mean, we can do all these other things, but can we just patch? Yeah, there's over 3,100 pieces of patch content that we provide for both Apple OS patches and third-party patches like Firefox and
Adobe and
yeah, all kinds of stuff, right? So that's just built in, and you could actually write your own patches too. But probably more interesting to a specific system administrator is some of this other stuff. And patches don't have to be pushed or scheduled to be installed. You can actually throw patches into our end user portal. When you do that, those patches are going to show up under updates, and then an end user could select and say, yeah, I want to run this patch now. So if it's something that's not super important, or it's something you want to give your end user control over when the patch gets run, you can throw it in the portal. And we have, I don't know how many of you have seen our new Mac portal, but it's pretty nice. We have some people who have a lot of years of experience in UI now on our team. They used to have people with lots of experience in not UI. That's me. I don't do UI. I used to have a friend that I would haul around from job to job with me because he was really good at UI, and I'm awful at it. But I do all that underneath stuff. So anyway, you can schedule patches in the self-service portal, and users can download those at their leisure. So, summary, patch is a powerful tool. You can do all kinds of cool things with it. We have customers that use it exclusively for their software distribution. They don't use software distribution at all. Of course, we also have customers that use provisioning exclusively for their software distribution, and they don't use software distribution at all. We have a whole lot of tools, right? Depends on how you want to use them and what specific things you want out of them. And you'll find a tool that'll do the job for you. Okay, before we move on, any other questions about patch? Okay. So, custom inventory information. There are only a few of our customers that even know you can do this on a Mac, to be honest. It's a feature that's been there forever, but we don't advertise it very well. Everybody knows you can do custom inventory information on Windows, but for some reason, people don't know you can do it on the Mac. It's probably because it's a little wonky how you do it. So let's have a scenario. And the scenario is we want to gather smart, whether smart is good or bad on our drives in our system. Now, I know today smart is becoming less and less relevant, right, with all the SSDs and stuff. They don't necessarily report back smart, but we may want to know this stuff. So, and we want it to show up in our inventory. So again, we're going to create a script. And in this case, the script is going to look like this. So we're going to have a file that's going to output some stuff into this library application support Landesk, custom data, and then arbitrary name. I called it smart.xml. It has to go in custom data, but the name of the file, as long as it's XML, we're okay. You can also useplists, but I find plists awkward to format from bash scripts. It's just XML is a little more succinct than plists, which is a little frightening if you think about it, because XML is not very succinct. I would like to move this on so we can use JSON and some other things, but we'll see what happens. Anyway, so what the script is doing, as you can see, is just echoing out some XML. So we echo out the XML header, and then we run disk util to get a list of information about our drives, throw that into a bash while loop, and then we're going to run some stuff. We're going to figure out some paths. We're going to run diskutil on those paths. We're going to extract information out with some awk. Do all the cool bash stuff. And again, doesn't matter. You could use whatever scripting language you like. I know Python's super popular. Use that. Use whatever you feel like. And then we're going to just echo out these individual lines that have drive, the drive name. So $drive is the drive name, and then the status of the drive. And then at the end, we do a close tag on our smart info, and we're going to so this will emit that XML, and that XML is going to look something like this. So not too bad. And then when we look at it in our inventory, it's going to look like that. Any questions there? Okay, so here's the tricky bit. There is no facility built into the core. Well, there is. I guess you could use a scheduled task, but it would be awkward, right? You could use a core scheduled task, and then the core would have to be constantly telling your all of your nodes to run this script occasionally to gather this information. And the core shouldn't be doing things like that, right? The core shouldn't be telling things to run to gather information. That's just end node related. So what we're going to do is we're going to leverage a tool that's part of the EPM agent. And this is a great little tool that nobody knows exists. So this is one of those tools that's in the bottom drawer that we only take out for really special situations. And that is the schedule. We have a local task scheduler as part of the agent. The task scheduler is every bit as cool and powerful as SD client is, right? It's kind of the SD client of scheduling. So it's loosely based on Microsoft's scheduled task format. Very loosely based. It's also semi-loosely based on Shavlik, which is another one of the companies that is part of Ivanti, their task format. But we've added cool stuff to it. So anyway, a task looks like this. It's a piece of XML. We have a list of triggers that tell us when to run. So in this case, I'm saying starting someday in the past, because I just want it to start up now. So the start boundary is when I want this particular task to start being relevant. I want to every day run this task. So on that top where it says start boundary, you see the 8 o'clock. So that's when it's first going to try to schedule. And then it's going to run it every day at 8 o'clock plus up to 120 minutes randomly generated, so that we're not always doing it at the same time. So that's what that random means, is it gives it a random difference in time. Okay? Now, that's a time trigger. There are lots of other kinds of triggers you can use. This is why the scheduler is really powerful, and you might want to use it rather than just use the core to schedule things, because we can trigger on whether the user is logging in, whether the user is logging out. We can trigger on whether if the network address has changed or something's changed in the network setup. There are a lot of different things we can trigger on that you can't really do from a core, right? Sure.
The machine's been idle for a period of time?
We don't have that, but that's a really good idea. That is certainly something we could make a trigger. So, yeah, so write that down, Randy.
Got it.
There are a lot of cool things we can do. But not only do we have triggers, we also have filters. And a filter says, take that trigger, but I only want it to run Monday, Wednesday, Friday. Or I only want it to run if the user is logged out. Or I only want it to run if the user's logged in. You can superimpose this filter on top of your schedule to mask out days or mask in days or mask out states or mask in states, whatever you want to do. Because you can also put a not on that and say, take this and not it, right? And you can also AND them and OR them together. There are lots of things we can do. I'm working on a big old document that we're going to publish. Aaron's going to help me, and it's going to be great. So we have triggers, we have filters. Another feature of this particular little application is we have queues. So it's just an arbitrary name, and I can say I can have something named inventory. And then no two tasks that are in the inventory queue will run at the same time. So it's a way to do mutual exclusion. So if I have several tasks that I want to schedule, but I never want them running together, I just put them in the same queue, and they won't run at the same time. So powerful. And then for the action, we just do, it's just a simple command line. You can't put a whole script in the action. So that's why we have to download a script and call it, because we just get just a command line. So anyway, that's how many of you knew anything like that existed in our agent? Yeah, it's really neat, and we should probably publish it more, and we should actually probably do some sort of little user interface to generate task schedules. But we don't. Someday maybe. So we're going to take that, we're going to organize our source. We'll have a bin. We'll have a bin directory with the script that's going to run. We'll have a scheduler directory with smartinfo.xml, and then we create a package. We're going to root that package at Library Application Support LANDESK. And now what it installs, it's going to throw the XML for the schedule into our scheduler directory. It's going to throw the shell script to run it into the bin directory. And as soon as the scheduler sees that XML show up, it's going to schedule it, and off we go. So in this case, rather than doing a patch, we're going to do software distribution. So we throw the package somewhere accessible. It just has to be an HTTP share. I'm just going to throw it onto my core in LANDESK files because it's easy. But I could put it, if I have other distribution points already set up, I could put it there. And then I'm going to go into software distribution. So software distribution lives there, distribution. And then I'm going to go into distribution packages. And I'm going to create, see, you can see, the new package. Hit that. I have two different types of packages I can create. I have a Macintosh agent package and a Macintosh MDM package. In this case, we want the agent package. Because this is not, I mean, you could do it through MDM, but then you have to set up to do a manifest package, and that's a lot of work. So for this case, we'll just do the agent. From there, we go ahead and we create our package. It's not super complicated. The main thing is that you get here, you have a path to the package that you're going to install. And then from there, we can tell it to put it into the portal, or we can tell it to just push it down or whatever. And then we create, again, we got to schedule that guy, right? It's got to be scheduled out. So we create a scheduled task. We drag a machine or machines onto the scheduled task, and we tell it to go. So, and then that will install that package. It will start the scheduler up, and it will add the scheduled item, and it will just go. So all kinds of interesting possibilities. It's kind of sad that we don't publicize this more, because I suspect our community would just go nuts with it and do all kinds of cool stuff. Sure. Right. Oh,
sorry. So
sorry. The question was.
You can just repeat it.
Yeah, the server is wherever the server lives, but we might have devices in different geolocations. Recently, they've added code that will deal with that. So it will schedule it based on the device location, right? Got to check with these guys.
Time zone sensitive.
Yeah, so it's all time zone sensitive to the end node.
Okay.
So yeah, no, that's a good question though.
But then for your like different geolocations, you create different groups of different tasks, basically.
You can create a different group or a different task, or inside the actual console scheduler, it's going to abide by that time zone of that device. So you could have a job start right now and in theory end in 26 hours to cover all the time zones around the world if you wanted to start at 8 a.m. in every time zone.
Right. So just in case the mic didn't pick that up, although Jason's voice, microphones pick it up. It's pretty good. If you schedule a large enough window, then all the time zones will be hit based on the local time zone, is what it comes down to. But once that XML, that schedule XML goes down, then it's purely based on the node, on the end node. Any other questions? All right. Okay, so managing configuration profiles. So again, configuration profiles are at the heart of Mac management, right? Of Apple management. And so, but we do something a little different. So configuration profiles live under something called agent settings. So we have our configuration. So if you go down to that bottom gray area, you select configuration. And once you've selected configuration, you'll see agent settings. When you go there, you will see this list of types of agent settings, and two of those types of agent settings are under Mac profiles. You have Mac OS configurations and Mac OS device configurations. Mac OS configurations will be installed to the user channel. Mac OS device configurations will be installed to the device channel. Okay, it's not too bad so far. So, but here's the deal. This is how things kind of get packaged up in the Ivanti world. We have configuration payloads. Probably everybody here is familiar with those, right? You have your VPN payload and your certificate payloads and all those kinds of payloads. Those get grouped into configuration profiles, just the way that we do all over Apple, right? But Ivanti takes that a step further, and you take configuration profiles and you group those into agent settings. So you get one agent setting of each type, device and user, for each machine. Now, that seems kind of limiting, doesn't it? But remember, you can group multiple configuration profiles into a single agent setting, and I'll show you that in a second. But this has been a point of confusion for some of our end users, because they will set up multiple agent settings for configuration profile agent settings groups and apply multiple agent settings. Well, if you do that, the last one wins, and you only get the last one. So the way this works is I go into the agent setting creation panel, and I get something that looks like this. Over on the left side, I have configuration profiles that I've created. And I create configuration profiles using our handy dandy configuration profile editor that lets you go in and edit, create payloads, create configuration profiles from those. It's something that came from LandRev when we brought LandRev, and it's pretty good. So you create your payloads, you put them into a profile, and then I take the profiles I want and I group them into a setting, into an agent setting. So I can have multiple configuration profiles installed on a machine, but they all have to live in one agent setting. And I can have those I can create multiple agent settings to target at different types of machines, but in the end, I get one agent setting of each kind per machine. Again, this is something that's caused some confusion. We had some long talks with end users at Interchange this year about how this works, because there was, Does that make sense to everybody, though? Do you get all the different pieces and how they work together? Okay. So, after that's done, the stuff that I'm about to tell you is about to be deprecated, because what you had to do then was you had to go into this drop-down in agent settings and pick a change setting, which would create a change setting task. Then you had to go find in this list your Mac OS configuration, and you had to pick it. And then that would create a scheduled task. With the next version of EPM, you'll just be able to right-click on the agent setting and say schedule it, and it will just happen. And I will be so happy. So anyway, configuration payloads will be synced anytime the device checks in. And if a profile has been removed, it will be reinstalled. So this is kind of a state thing. This doesn't work the way software does. Something important here, though, configuration profiles can be installed either from the command line, the old way, the agent-oriented way, or through the MDM. Well, Apple is making all kinds of noise that says that command line installation is going to go away at some point. We don't know when, but we know it's going to happen. And besides that, there's all kinds of problems with installing profiles through the command line. So what happens in Ivanti EPM is when we push out an agent setting, if it's a configuration profile setting, the agent goes, am I enrolled in Ivanti MDM? I am. Well, then I'm not going to install this. I'm going to let the MDM do it. And then it'll be scheduled to come down in the MDM, and the MDM will push the settings down instead. So if you have a device both MDM enrolled and have an agent installed on that device, configuration profiles will always come down through MDM, which is a good thing. Okay? So any questions about any of that? Any more questions about profiles? Okay. So let's look a little bit towards the future then. We're going to talk about the Ivanti cloud, which is coming along. And I am still exactly on schedule. So EPM's powerful, but Windows-only console. Oh, I hear about it so often. Why is your console so big and ugly in Windows E? It's a problem. And then the other thing is everything is on a schedule, right? You always have to schedule these things, and we're not very reactive. If one of my developers deletes Discord, then it's going to be potentially a day before he gets it back, right? It's all scheduled, so that's a problem. So moving forward, we have this thing called the Ivanti cloud. Have any of you guys seen it at all? Okay. So the cloud. It's a web interface, so no more big ugly Windows console. It pulls together it's pulling together, we're not done yet, but it's pulling together pretty much everything Ivanti does, which is a substantial amount of stuff, plus everyone else's, right? We're very inclusive. The development cycle of it is a DevOps-based development cycle. And they've told us we have extreme ownership, which means that the development groups, our development teams, can push out updates almost at will. There's some gating going on there to make sure that things are more or less stable, hopefully more stable. But we have the ability. We don't have to do just a once-a-year release anymore. We don't have to wait for a service pack anymore. When we see problems, we can fix them and then go through gates, and it might be a day, right, until we can actually get the fix pushed out. So we'll be a lot more responsive. And one of the big features of this whole cloud thing, though, is that the triggers are now real time. So instead of waiting for scheduled things to happen, we can tell the devices to look for specific events, and then we can notify up the chain that the event has occurred and take appropriate action based on that. So in the future, when somebody deletes that Discord app, it will come back down fairly quickly. So the guts of that, the heart of that is this thing called RealTime Intelligence. And I have some slides for that, but it was working really well. So I'm going to try to do a demo, and if the demo gods frown on me, then I will go back. I've got a bunch of slides, right, to show you. I'm backed up, but we're going to try to do some real-time, right? So we're going to go to the cloud. So this is what the Ivanti cloud looks like. Let's see, maybe I can give that just a little bit. Ooh, that was interesting. And we'll make it. And you can see, I can look at my devices and see a bunch of devices. And I'm going to talk more about this view in a minute. And then we have this real-time intelligence thing. And this really is important because we're going to talk about some real nitty-gritty details of this in a minute. But I can go out and I can say, let's just look at my operating systems that are installed. So it's actually going out and it's asking all these machines. It's not looking in a database that it owns. It's going out and it's querying 110 machines saying, what are you running right now? Get that information back, and I can go through and I don't know why we have so many CentOS in here. We love Linux these days. I can look and see the different operating systems here. I can put it into a table view. I can search. I can look at my machines by doing that. I could go in and I can say, ooh, what's going on with my MacBook Pro? It'll go out and it will find information about it. It'll tell me that I'm here in State College. And it will, one of my favorite pieces about this. So the Windows guys, as part of the standard information for this particular view, they put in this reliability index, which is something they ask Windows for. So we have a hard-coded reliability index of 11. All the Macs, their reliability is 11.
The scale is 1 to 10.
Yeah, the scale is 1 to 10. But our Macs go to 11. Nobody's complained yet. So someday they'll say, hey, wait a minute. Anyway, so I can also, from here, I could go here, drill down and say, oh, here's all my specific machines. It's still out looking for stuff. I can see what my machines look like. Anyway, you get the idea. It's kind of interactive. It keeps things up to date real time. I can do things like, this one's kind of fun. I can go ask about, now this query takes a second because the Windows guys don't have this sensor yet. I'll explain sensors here in a second. So they have to say, I don't have it. Let's see, probably everybody who's, yeah, so here, oh, no, not yet. Oh, there we go. So here you can say we've got a device that's enrolled in Heats MDM, which would be LANREV. And somebody's enrolled in Micro MDM. I thought I had one on here that was enrolled in Ivanti. It must be taking a second. So anyway, it's not, we will detect the information not just for our own MDM, but for other people's MDMs. So we can say, oh yeah, they have or haven't approved their profile. They are or are not a DEP machine, all kinds of stuff, right? So we can get all this information. And we're going out, we're asking the machines real time. This information has been integrated in, so this is the device display. What we're seeing here are not only our real-time devices, but devices that have been imported from EPM, because we have a connector that will suck EPM devices out. And if we look, let's just, oh, it won't let me, can I sort on that? Let's just look. So anything that says real-time enabled, then that's something that's actually running the Ivanti agent, not the EPM, or not necessarily just the EPM agent, I guess I should say. So all those other guys that weren't enabled, they're running the EPM agent, but not the real-time agent. All these guys are running both. So if I go and I look at a device, so we look at my Mini 12, then that's interesting. Our spinner got drunk for some reason there. I can go and I can look at detailed view of it, and I can look at my MDM information. All the regular inventory stuff that you would see in EPM. So I'm not sure what's going on there. And then also, but that has been integrated with real-time information. So in the main view, we'll get some static information that we got from the EPM agent, but we'll also get real-time information that comes from the real-time agent. Kind of cool, right? So these are kind of the things that are going on going forward. But one thing that we wanted to do from the Mac side, and we're going to go back to the slides. Any questions about any of this? Sure. What was that? Yeah. And I suspect one of these guys are going to have to answer that. Go ahead.
The cloud device FedRAMPed?
FedRAMP, no. Ivanti Cloud is not FedRAMP. Our service management piece that's in the cloud for our ticketing solution, that is FedRAMP. Ivanti Cloud is still going through the FedRAMP process, but as of this hour, it's not. We can get you in contact with the actual cloud product guys that are running on it to give you a little better idea on it. But our ticketing solution it's the ISM, Ivanti Service Manager. That is completely FedRAMPed and certified.
It is in the process. It just takes a long time.
Yeah.
Oh, yeah, you know, but it's in the process.
Yeah. It's not a forgotten piece. It's just not there yet.
So just kind of, again, some of the things that are in here. We have connectors. So we get discovery information from the Ivanti agent. You're going to have to listen for that. There's the Ivanti agent and there's the EPM agent, and they're separate. We get that real-time information from Ivanti agent, but also we have a connector for Ivanti EPM, which will suck information out of an EPM instance. For, I don't even know what that one is. You can import stuff from CSVs. We have a connector for SECM. We have a connector for AD. All these things will pull information from all these other sources, and there are ways to go in and try to rationalize that and figure out what's what there. It's kind of fun. Anyway, lots of information there. Plus, in our automation, so the piece that lets us actually take actions. Again, we are very open-minded. Oh, come on. I just clicked too soon. You gotta let the page load. So not only do we have connectors to take action on like Ivanti pieces, like Ivanti Service Manager and such, but if you look, we support, you can take the action on AirWatch, on Zen Mobile, IBM, all kinds of stuff, Mobile Iron. We have connectors to go out and talk to those other vendors as well. So we just want to give all of IT a great big old hug. Bring it all in one place, have it played well together. That's what's going on here. So anyway, that's the cloud. Any other questions about the cloud? That's funny. I saw I have a message on Slack and it's like immediately wanted to go answer it. Go ahead.
So you can, like I saw one of the medallions showed up with CPU usage,
Mm-hmm.
and it's collecting that real time. But can I get historical stuff and run reports on that? Like, can I sort on my computers by, like, over the last day, which ones that were at 100% CPU?
So they are adding a trend ability. We've heard that request before. It's not in yet, but it's active work is being done on being able to gather trends and make decisions on trends and things, historical information.
You know, like, which machines are running at 100% of RAM?
Right.
You know, or people say, my computer's always slow, but then you pull it up and over time, it's never over 50% CPU.
Right. Yeah, we've heard that request. Now we can put a monitor on it. So the other side of that is we can put a monitor down that says, notify us if this happens. Right? So notify us if their CPU does spike, and then you could attach actions to that to do some more discovery on it. But yeah. So let's go back to the slides for a second. And let's skip down. There's my bear hug slide that I don't need to do. So again, I said, like I said before, the difference is the Ivanti agent. Let's see, did I switch back? Separate display. And that's weird. Oh, I gotta hit play. There we go. Okay. So how the Ivanti agent works. We have the cloud. Then we have the Ivanti agent on each endpoint. And then the Ivanti agent's job is really to manage engines. So we have a real-time engine, and it's the guy that actually goes out and it gathers all that information. We also have an inventory engine. We have an automation engine. We're working on our patch engine for the Mac. We already have a patch engine for Linux and Windows. So we have these engines that we're creating, right? And the agent checks versions of those, looks for updates, and it just manages all those engines. And it facilitates communication from the engine back to the server. So in the case of real-time has a bunch of sensors. And the sensors are dynamically loaded, and they're discoverable by the real-time engine. So I can drop a sensor into a specific directory, and the real-time engine will pick it up and say, oh, this sensor's here. It knows how to handle these questions. So now if this question comes through, I will talk to it. So now from a Swift standpoint, and we're going to get probably more detail than people want here, but engineer, you're going to have to live with it. From a coding standpoint, the main program for any sensor looks like that. I say I import, this is Swift, I import the Pulse Sensor SDK, and then I pass an instance of some class that defines that sensor that I want to write into the sensor main, and I'm done. Okay? So if I were you and I wanted to write a sensor in Swift, I would write those 2 lines of code, and then I would create a sensor, that class that was the actual sensor, and all I need to do there is I need to map a message, so just a text string, to a function, to a procedure, and then implement that procedure. And I can map as many of those in a single sensor as I like, and I can do queries, I can do actions, and I can do monitors. Okay? And then in the info plist for that application, I tell it, I have to specify the messages that sensor will handle, and then this is how the real-time engine decides what the sensor will do. So we have a Xcode template that we're tightening up and we're going to publish for people to write their own sensors. But not everyone does Swift, right? I'm guessing most people at this conference aren't real big Swift programmers. And so we have script sensors. Sensors are just bundles. In the case of a Swift application, it's an application bundle, but it's still just a bundle. So I can create a info P list, put it in this bundle, and I say that it is a script, and I tell it what the script is. So now you can see here, I have my description, and I have my output format that I'm going to be a P list, and then I have the script. It's going to be a diskusage.sh, and then that diskusage.sh is going to be called when somebody does a query of that's called drives. I don't have a highlight for that. So at the bottom where it says type drives, that's the string that it's going to react to. And if I build my little bundle like that, I don't have to put any other code in there. And the sensor is going to, or excuse me, the engine is going to walk through, once that shows up in the directory, it's going to walk the directory, say, hey, this guy is a script sensor. I'm going to map this shell script to this query, and whenever that query comes through, the shell script's going to be run. Some of the sensors that are already in here are, that you saw running there are script sensors. We use them ourselves because sometimes it's just easier. One of them is written in Perl. I don't know why. Jens thought it would be fun to write something in Perl. You can use any scripting language you like. We're going to allow it. So if somebody, we're hoping that we can get that whole Python community up and going and write some really cool Python sensors for the Mac. So that's real time. And I've already done the demo. So that's most of this. That's the session, right? That's the stuff that we have to talk about today. Are there any other questions? Any questions about anything? Go ahead. Whatever. Any EPM any Ivanti related stuff. We can probably help you out. But specifically about EPM or about what we're doing with Apple.
So we've got.
Oh, do you want to get the box back there? Oh, what? It's all the way up here. I'm a terrible thrower. Here, let's see. Can we relay it?
Okay. So we've got a bunch of patch licenses for Windows.
Mm-hmm.
Or I don't know if the licenses are different or not. We bought 3,500 licenses of patch, and we've been using them to third-party patch our Windows clients.
Mm-hmm.
Can I use some of those licenses for the Mac? Is it
Yeah.
a totally different product?
Nope.
It looks like it's the same
It's
thing.
the same product. Node's a node.
Okay. So we could throw some Macs in there and do some stuff with it.
Absolutely.
Cool, because I think we're going to buy a whole bunch more for...
Your subscription's good for the Mac app downloads too. So if you go in and select Mac vulnerabilities, you'll get those too. So
Yep.
you don't need to do anything else.
Cool. What's the next?
Anybody else? Well, great. I'm pretty much right on time. I figured I'd have about 10 minutes for questions if we needed them, and that's where we ended up. If that's the case, thanks for coming. Hopefully you'll get something good out of this, and I guess they're taping this so you can show your friends that didn't show up, because there's good stuff.